Alright, solve the radical equation. It says check all proposed solutions. So that's a hint that we might end up with some extraneous solutions. And I'll explain what that means and why that might happen. But in order to solve a radical equation, we want to get rid of the square root. So the first step would be to isolate that square root. And it is already isolated, so we don't have to worry about that. What we do need to do first is just to go ahead and square both sides. So 35 minus 2x under the square root. Right? I'm going to square that side of the equation, and then I'm going to square the right side of the equation. And then the reason we squared was because we know that that square root and that square are going to cancel each other out, which means we have 35 minus 2x over on this side. We have x squared on the right. So now I've got a quadratic equation, and to solve that I'm just going to set it equal to 0. We could move the x squared to the left side, and that's not a problem, but I like to keep the x squared as positive. The leading coefficient is positive, so to do that I'm going to bring everything to the right side. So I'm going to subtract 35 from both sides and add 2x to both sides. So over here we're going to have plus 2x and minus 35. And then, of course, on the left we'll have 0. So I've got 0 is equal to x squared plus 2x minus 35. Now, the very act of squaring both sides of the equation could introduce an extraneous solution, which just means you could introduce a solution to this new equation. The new equation is 0 is equal to x squared plus 2x minus 35. We might have a solution to this that is not a solution to the original equation. So just by squaring both sides, we have to be careful and check all of our solutions, because one of these, or maybe both, could be extraneous. Actually, it won't be both, but you should check both. We got to continue to solve this thing, so we just see if it'll factor, which I'm pretty sure it will. So we have x and x. I need two things that multiply to be a negative 35. And also add to be a positive 2, so that'd be a plus 7 and a minus 5. Now we have these two factors equal to 0, so we set each factor equal to 0 and solve. Well, x plus 7 equals 0 leads to x is equal to negative 7. And x minus 5 is equal to 0 leads to x is equal to 5. So those are the two things we need to check. Now if you plug in negative 7, you can tell right away that won't work, because what would happen is this. I'd have 35 minus 2 times negative 7 is equal to negative 7. Well, right away I know that if I'm taking the square root of something, it can't be negative. The square root symbol, in fact, is for the positive, the principal square root. So no matter what ends up under that radical, when I take the square root of it, I can't get a negative. So we eliminate that option. So we know x equals negative 7 is not part of the solution. But if you're not buying that, then just go through with the full check. The square root of 35 plus 14, right? Because negative 7 times negative 2 times negative 7 would be positive 14. So this is the square root of 49. Well, no, the square root of 49 does not equal negative 7. The square root of 49 is equal to positive 7. So this would be not true. So you can carry the check out all the way through and show that these two things aren't equal to each other. Then we can plug in 5 and see if that works. And that one should work. 35 minus 2 times x is 5 now. Does that equal to 5? So it's the square root of 35 minus 10, so that's square root of 25. Well, yeah, square root of 25 is 5. That does equal to 5. So that checked out. So the only solution is x is equal to 5.